So Eric, thanks again for being here and stepping in.
It's great to be here, and I want to extend Vic and Bates' apologies. Also, his airplane had mechanical difficulties this morning, but I'm very excited to be here with you.
No, we're in good hands here. I think there's no better place to start than talking about Current. It's been described as a startup. It's a billion-dollar business within GE, though. So can you talk about the technologies that sit within it and the impetus to bring those together, and how you guys dare call it a startup?
Yeah, so it's an exciting thing that GE is working through. So we're carving out exponential technologies within the company and pulling them together to work on a new energy platform. So when we think about it, it has our LEDs, it has the solar, it has battery energy storage, it has electric vehicle charging, and then it has on-site power. And we've pulled these together. And each of these technologies is following an exponential curve. So LEDs are following Moore's law on the cost point down. If you look at battery energy storage, it's halving in cost every 5 years. You would take a look at solar, or on the solar side, it's coming down also. And these technologies, when you pull them together, we know the cost points are getting better and better over time. We then tie in the industrial internet, where we have more and more cloud computing, other things with that, where you can do the analytics, you can pull together the data, you can control more and more points. Instead of controlling a couple of hundred or a couple of thousand power plants, now we will be controlling hundreds of thousands or millions of endpoints when we do that and pull that together. And then lastly, new business models, where instead of selling capital products out, we're exploring things such as lighting as a service, where it's more of an OpEx rather than a CapEx, where you pay for time of use rather than paying for the capital going in. The convergence of these three things, each of which are happening exponentially, will really help the distributed energy resources take off.
So can you talk a little bit about what that actually looks like today? You have some early clients, mostly on the corporate side. Hilton, JP Morgan Chase is doing a huge LED project with Current. But obviously, particularly when you talk about just the LEDs before you start layering on analytic capabilities and providing other solutions, what's the first step of that look like? And then what's that look like, maybe a couple years out in terms of some of the capabilities that corporations like this might be leveraging from Current?
Yeah. No, that's a great question. So when we look at the JP Morgan deal that we just signed, and we're starting an execution right now, that will be for 5,000 locations for JP Morgan. It's a $200 million deal. And we're going to be retrofitting about 50 sites a week for the next 100 weeks across their facilities there. And it's going to cut their energy costs in half. And that's a big step forward when we look at how much electricity. But not only that, we're looking to make these controllable sockets, where we can go ahead and gather the data, we can control the sockets. It starts making the availability of demand response, other ways to approach it, shifting loads when we look at it with JP Morgan. With others, we're trying to do the same things, but we're also tying in solar, tying in battery energy storage, behind the meter battery energy storage, as well as in front of the meter battery energy storage. And the goal is to work on three things. Work on reduce electric consumption through LEDs mostly. We look at shifting, so you can shift the peak, so demand charges and other things can be affected. We do that through battery energy storage, and in the future through electric vehicle charging. And then we do production. How do you produce? And the production is through the solar and the on-site power, whether it's combined heat and power, other forms of on-site power. And then we want to wrap around it an optimization layer, where we can go ahead and optimize the energy usage within the facilities.
So for a client, all of these clients that you have are already very sophisticated power users. They have people dedicated to thinking about these issues. Can you talk about, even so, I was with you guys ringing the bell recently when you guys closed the New York Stock Exchange, and even some of these corporate clients talked about how difficult it is to think holistically about these instead of here's an LED retrofit, here's solar at this site, maybe here's a CHP project over there. And it seems like what Kern's trying to do is bring this together and help corporations to begin with, but also municipalities and utilities think holistically across this. And can you talk about that challenge? Because even with the most sophisticated, Fortune 100 companies, it's a challenge.
Yeah, so one of the things we've done is we've worked with our Global Research Center to develop very sophisticated models for how we can take electric bills in. We take weather patterns, electricity usage, even water usage, other things, we can tie that in and come back with the optimal solutions. Many times a customer will come to us with a solution in mind saying, I'd like to put solar on, or I'd like to go put in a different type of technology. We will look for the optimal solution. Now, we'll always provide whatever the customer wants, but we'll try to put the optimal solution together based on whatever the time of use charges are within the utility, how the electricity billing happens, what the patterns are from the customers. We'll tie that package together and then offer it back to them in the most economic way possible. And these are very statistical types of things. Historically, we've looked at energy deterministically, where you can do a calculation and it always ties out in the end. Many of the things we're working on today with so many endpoints and so much variability, we have to do statistically, and that's where using our Global Research Center or some of the work that our data scientists at our Software Center of Excellence can do can really help out the optimal solutions.
And your Predix platform as well, you have a lot of developers open up and working on that. Can you talk a little bit about, within energy, some of the solutions and areas you're hoping you're going to see some really interesting innovation in the next couple of years?
Yeah, and so as GE, we've really embraced the next wave of innovation with software, the industrial internet, Internet of Things, many different names for coming through here. So Bill Rue spoke here a couple of years ago. He's our software leader for GE Digital, and we built up over the last 5 years. We went from having no software engineers at our center in Silicon Valley to now we have 1,200 software engineers and data scientists. So we built up an entire organization out there to build up these capabilities. We also stepped out and we created what we call our Predix platform. And the platform is really a way to pull together all the data. It's a bit of a network fabric, so it can pull all the edge devices, all the data forward. And by doing this, we now have enough data where our data scientists can really dig in, get into the heart of the matter there. And our goal is to tie together the data, the physics, our physics-based understanding, and statistics, to really tie the three together to get the optimal solutions. Because many times statistical solutions are great, but they'll tell you that something's happening. You can find a pattern recognition in the data. Sometimes you have to go back and really dive into the physics for what are you going to do about that. And when we look at it in the energy space, a couple of things jump out. We're doing a lot around our power plants. We're having our power plants run much more reliably, or we can also run them harder, so we can run them closer to physics-based boundaries because we understand the physics and the statistics and we have the data. We also look at our wind turbines, where we've been able to do reliability analysis on wind turbines. One of the great products is where we are doing real-time digital twin of a wind turbine, of how it's operating, but we also compare it to the closest wind turbine next to it and then the most common wind turbine to it with the similar operating conditions across the entire fleet of 20,000 turbines. And that way we can figure out when things are happening to that to make it run more reliably. And then through our model-based controls, really getting in and understanding how to control the wind turbines, we're able to run the turbines harder. And we can give an additional 150 kilowatts worth of power during certain time periods, which is free power because the fuel is free on that. So a lot of activities there.
Are you doing that now? Is that in operation?
Yeah, so we have a product called Power Up right now where we're able to do that with our wind turbines, and that's very exciting, and the reliability is already happening through our monitoring diagnostics center. When I look at the grid side, we're doing a lot more with distributed energy resource management systems, DERM systems. Right. We're doing more with DMS systems, distributed management systems. We're doing even EMS. And one of the keys when we look at the grid side is that we just went through the acquisition of Alstom Power. And that was a great merging of capabilities across two large energy companies. So now 25% of all the world's power generation is by GE equipment that's out there. And we also, on the grid side, GE was very strong in the distribution side. Alstom was very strong on the transmission side. Now we've merged those capabilities, so we have the full linkage there. If we look at the renewable portfolio, significantly expanded also because Alstom was very strong on offshore wind.
Right.
We were strong on onshore wind. They were strong in hydro. You put all that together into one renewable energy business. And these are the types of things, because having that entire energy portfolio matters. So, you know, when I look at GE today, we've transformed ourselves over the last several years where we do the extraction with oil and gas on the oil and the natural gas side. We do the conversion on the power generation, whether it's wind, nuclear, gas on that side. We do the transmission and distribution. And then we also do the utilization side of this with current stepping in.
Talking about Alstom and some of the synergies between the two companies and grid technologies, one of the projects that you have here with ARPA-E is the HVDC gas switch that you're working on. Can you talk a little bit about what that is? And I heard yesterday when I was down on the showcase floor that Alstom, from day one as you were going through the acquisition, was very interested in this technology and actually had been thinking about something similar but didn't have some of the holes filled in. And so can you talk a little bit about what that is and what that means potentially for efficiencies for HVDC?
So we're very excited about the work we're doing with ARPA-E and really enjoy the partnership. There's actually 6 projects that we're working on, this being one of them. And bringing in Alstom really helps with this because they have a lot of HVDC capability and actual products in the field. We had very strong research at our Global Research Center. And this switch is using plasma as the switch. So you actually have active plasma inside the switch that makes the connection. And it's able to significantly reduce the size and hopefully over time significantly reduce the cost of the HVDC switching, which is one of the challenges today. And HVDC is becoming more and more important, especially when we look at renewables, because as you have offshore wind, more and more HVDC lines will be necessary for that, undersea lines, because of the current carrying capabilities and the voltage capabilities of HVDC. Very important to have that as we go forward. And then also, even as we look at in oil and gas, it's become more and more important when you look at subsea power and processing, where we may have 100 megawatt facilities underwater, all driven by electricity. HVDC will play a key role in that, especially as you get to longer and longer step outs.
Yeah, certainly some parts of Asia, much of Europe has definitely been investing in modern HVDC in a way that we haven't seen here in the US. There's a project in Vermont that recently was approved that is one of the more modern ones that's definitely going to get done, unlike some other HVDC projects. Can you talk a little bit about how you see that changing appetite here in the US? Because it seems like in the next 5 years, we might really see an uptick potentially, given renewables penetrations and potentially if technologies such as plasma and a switch could bring down the cost further.
Yeah, so you know, the HVDC is becoming a much more viable technology. There were a lot of reasons that China did it due to the distance, due to not having the grid infrastructure already there to take some big steps there. We see the potential for more and more of that happening in the US. Probably too soon to predict how fast that's going to happen, but HVDC does have efficiency capabilities there. Also doesn't necessarily have to be synchronous as you cut across different grid systems. There's a lot of benefits to it. It's a matter of when do the cost points hit the viability limit and it starts being more into production.
Yeah. We heard Al Gore talk a little bit about millennials, about their interest in sustainability and the companies that they work for. most people have probably at some point seen the GE commercials with Owen. His dad's sad he can't pick up a hammer. His friends are confused that the apps he's working on don't involve cats. The commercials never mention HVDC. They mention, they mention transportation. They mention healthcare. Some of the nitty-gritty grid issues that GE works on in some of the innovation that's really needed in that sector didn't quite make it in the commercial cuts. Yeah. But can you talk about a little bit, you mentioned obviously the huge team that you guys have built up in a few years in Silicon Valley, but the competition to attract and retain the sort of talent that you need to push some of these industries forward with the technologies that you guys help, particularly to the utility industry. Would love to hear how that continues to evolve.
Yeah, and sustainability is something that has been hugely important at GE. We launched our Eco-Imagination initiative over 10 years ago, already saying that we would cut our carbon footprint, our water footprint, we would drive energy efficiency, and we exceeded all of our targets, and we've now extended that for 5 more years. And it's the right thing to do, and it makes us money. And so when we look at that, the right thing to do side really helps us attract a lot of the talent there, because a lot of the millennials want to work for a company that cares about the environment, that works on sustainability, and it's important to us. Plus, as we step into some of these areas, not only is it the eco side of it, but it's also the way we work. So we're transitioning the way we work internally. We have a big initiative around what we call Fast Works, where we want to act more like startups inside. Not in everything we do, but in large sections of what we do when we're developing.
So what's that look like beyond a ping pong table?
Well, no, I think, and we've tried the ping pong tables in the past, and it's got to be more than that, and not too good.
Okay.
But it's really around how do we embrace the lean startup methodology. So Eric Ries, the lean startup methodology, where instead of using a stage gate process and saying, I need this product 5 years from now, it's how do we build small experiments? How do we go out there and say, these are my hypotheses? Instead of stating them as conclusions, here's the 4 or 5 things I need to test. Give a little bit of money, a couple of people, and go test those hypotheses. If you get done with that, okay, now we're going to have a decision and we're going to pivot or persevere. We're either going to change direction, we're going to keep going on the same direction that we have going now. And how do we run ourselves just like a venture capital would be trying to lead a startup for each of these experiments?
Let me ask, because Mario Sylvester is a CEO of Current, said a couple weeks ago at the closing mail, she said, we're not afraid to break a little glass. And I'm wondering how much glass potentially you're willing to break and going through some of these processes. And for you, you've been at GE a long time. In other sectors of the business, and certainly years ago, the idea of breaking some glass to get where you're going was not the approach. And so just for you, that you didn't join from somewhere else recently, can you talk a little bit about that and what that pivot means, for people who've been GE for decades?
And we need to be able to understand the value of learning. So if we spend $10, $50, $100,000 and we learn something that makes us stop a program, that's money well spent. And we have to embrace that. So in my prior role where we drove this very heavily, we got ourselves from about 10% failure rate, so only 10% of the projects we started, we actually stopped before the end, to we got up to a point where about half of the projects, so we were expanding what we would start, because you have to expand the envelope to go ahead and get as many ideas as you can into the funnel, and then half of them wouldn't make it through, but the half that made it through were better than if we would have used the old process. And it took a little while for us to get comfortable with that, because it's not necessarily something that 20 years ago would have got you promoted inside the company.
Right.
But now coming up with great ideas, continuous learning is part of the culture, and we got to keep driving this every day.
On that note, it might be good to talk about energy storage. You guys have moved into working in lithium ion. Can you talk a little bit about where GE's energy storage business is today?
Yeah, so energy storage is going to be a critical technology in the future, and we are in on energy storage. We have a group that's doing mostly grid level energy storage right now. We have a contract with Con Ed where we're putting in an 8 megawatt hour battery system with Con Ed. And this is one that's mostly for shifting power, because batteries are fantastic at either shifting or at stabilizing the grid. This is more of a shift project where there's an existing solar field. We want to be able to store that because the grid can't absorb all of the solar power at that point. We want to be able to capture that and then use it at another time. So it's a 2 megawatt power, 8 megawatt hour battery system. Good application there. We're excited about that. And as I mentioned, costs in these systems continue to come down over time. We also have a great project out in California with IID, and that's a project more on grid resiliency. And it's a 33 megawatt, 20 megawatt hour system, and it's set up to do frequency regulation, voltage regulation, and even black star capability in case there is an outage in that area. And batteries today can do a lot of things that would take several other pieces of equipment to get done. Now it's a matter of when does the cost point come down, when does the viability hit for batteries. In many places it's today, but it'll start following similar curves of solar in our estimations.
Right. IID, certainly their investment in storage was driven by, in part by some regulatory issues after they had some reliability issues. Con Ed, on the other hand, is trying to solve some issues. They have some parts of New York that peak very late, up to like 11 p.m.
Right.
They're trying to look at non-wires alternatives to some of the congestion issues that they have in Brooklyn and Queens. There's some very specific cases. Can you talk about working with utilities, particularly within current? Because I know that currently you guys are working with corporations now, but certainly utilities are part of that. But there's certain states that are putting more and more interesting regulatory mandates on utilities to think and act differently. New York, California, Hawaii, all for slightly different reasons. But can you talk about what that will look like for current to work with utilities, not only in maybe some of these more interesting emerging regulatory environments, but then across the other 40-something states where regulatory innovation looks slightly different or is a non-start?
Yeah, and when I look at the emerging ecosystem that's coming, there'll be some technology that'll have to improve, and the technology's following very aggressive curves right now. There'll be new business models that'll have to emerge, and then there'll be new regulatory environments that'll have to emerge. And to your point, New York with New York Rev has a proposal out there around what it thinks that the future will look like with microgrid technology, other technologies happening there. You have California taking some steps forward in those areas. So we're very active, and we're fortunate that with what we call the GE store, where even though we don't have the individuals within current, within our energy connections and grid solutions groups, we have people that in our energy consulting that work with these regulatory agencies to help look at this. But when we look at where this is going, I think there's going to be experimentation to try to figure out what the right ways forward will be. We want to engage in that. There's a lot of tests that are being run today as part of these programs, and we want to get more and more engaged. Part of the reason for pulling current out and doing this is so we can engage more with California ISO, New York ISO, and others around these tests.
Maybe you can talk a little bit about what that looks like, whether it's helping utilities solve issues around distributed energy, resource integration. I know that you guys are working on advanced load controls and forecasting. It's a really, really interesting area. There's so much work left to be done before, particularly looking at grid edge resources being brought into long-term forecast planning. Can you talk a little bit about what projects like that look like and how you're working with utilities on issues like that?
I think the solutions of the future will solve for two things. It'll solve to help the consumers, whether it's commercial, industrial, or an end user, reduce their energy costs and use it more efficiently. But then also with the utilities, help them manage these distributed energy resources. So the solutions in the middle are going to kind of look both ways as they play out. And a lot of it has to do with my earlier point around the stochastic nature of what's happening here. So how do we help with forecasting? We had another ARPA-E project around the forecasting and pulling in weather data, pulling in patterns of the past, pulling in some of the data from the usage that's taking place, and tying together these models and then utilizing self-learning algorithms to go ahead and learn, because many of these solutions will not be able to be done deterministically, to just write an equation and it solves for an equation. It's going to have to pull together, tens and hundreds of points in there and try to tie those together in a self-learning algorithm. And this is the type of projects that we're going to need going forward. So we have the solutions, the supervisor control systems that ride on there, whether it's a DMS or an EMS system. We have all that today. Now we're putting a predix layer on top of that and a cloud layer up there where we pull the data in, we do the analytics in the cloud because of the computing capability that's necessary, and then feed that back down again. So the architecture is going to go from the edge devices to the supervisor control systems up to the cloud and then back down again. And this is going to be across thousands of points when you start looking at distributed energy resources. So the challenge has gone from a hub and spoke central control to a distributed network, and the solution has to really expand as we do that.
What's that look like if I'm an operator sitting in a control room? I certainly don't want one more screen in front of me. At a utility, many utilities have sort of utility of the future groups, some more futuristic looking than others. And those groups don't necessarily at this point interface, into operations. Some of the operations folks are sort of waiting back to see how far some of these projects go before they necessarily want any of this involved in their side of the business. GE's been doing this a really long time. Can you talk a little bit about working within that world?
And so making it easier on the utilities as well as making it easier on the consumers. One of the potential scenarios is that this is going to be aggregated into a virtual power plant. That you take many of these points, you aggregate it into tens or hundreds of megawatts, and then you dispatch that into the utility as though it's another one point on the grid. So it wouldn't be a new screen, it wouldn't be 1,000 new points, it would be one new point on their screen that would be the same as dropping a power plant in. And that aggregation is going to be an important step. That's one of the scenarios. There's other scenarios, but that's the one that we think is a likely outcome going forward. We also feel that there's a potential to utilize this type of capability either for the power side or for voltage regulation, which is also very important in this space, to offset the need to put new copper or new steel in the ground and offset that with possibly the voltage regulation and smart inverters or other technology there going forward. So the goal is that this should be something that's synergistic and easier for everyone to work with, not something that complicates what people are doing.
Yeah, we're certainly seeing modern non-wires alternatives becoming more common, certainly in New York under REV, but there's some going on in Michigan, there's some being considered in Florida in a way where they're leveraging battery storage. They're not just efficiency non-wires alternatives, they're leveraging batteries and more sophisticated demand response technologies than we'd seen in the past. And I think there's just going to be a whole lot more of that going forward, mostly regulatory driven. But I think utilities as well are interested in looking at them now that there's a maturation of technology there. We've been talking a lot about predix and sort of the digital layer, but you have some other really interesting ARPA-E projects that are more on the materials side. You guys are doing a lot with silicon carbide that has a lot of applications across what you guys work in at GE, but particularly in medium voltage switching on the grid side. Can you talk a little bit, maybe we can start on the grid side and then talk some of the other applications, LEDs and beyond.
Yeah. So silicon carbide is exciting. It's something we've been working on for a while, and we're looking forward to working with ARPA-E more in this area. But it has efficiency capabilities well beyond what current power electronics have today. And with efficiency comes heat, because across inefficient devices, you wind up creating heat. So, and that's a challenge. So lowers temperature, improves performance. We're looking to get a couple of points worth of performance, and it doesn't sound like much at that level, but that could cut your losses by 50% potentially when we start looking at what you can do with silicon carbide. Again, it's got to follow a cost curve, but we think we're in the right distances here. And so that will allow more power electronics for grid solutions, grid level solutions, bring the cost down, bring the size down, a lot of steps in that area, versus using what today may be static VAR compensation or transformers or other devices out there that can do multi-purpose with these new power electronics. And then you start bringing this down, and one of the projects that we're working on is how do we apply this in drivers in LED fixtures. And so you can go from the large devices to the medium devices all the way down to the small devices. And again, with more efficiency and less heat, you can take a lot out of the cost of the devices. But then if every lighting fixture in the world, you take a point of efficiency and get a point of efficiency on it, that's a tremendous amount of power that comes out. Because if you look at all the buildings in the US anyway, about a third of the power consumption inside of industrial buildings and commercial buildings is through lighting. So it's something where that can have a significant effect.
Lighting obviously is the way in for probably many early projects for current, certainly seeing it with JP Morgan and Chase. It's potentially just the tip of the iceberg in the sorts of ways you might work with some of these clients. We haven't talked about municipalities, which is another area that lots of people are targeting. And certainly lighting projects, street lighting projects are another way in. And then there's endless promise of what can be layered on top of that. I can only imagine the sales cycle going through siloed municipalities, talking to them about different applications for these projects. Can you talk a little bit about the challenge of working with cities, given the immense promise that there is there?
Yeah, and so we have a couple of projects we've already done with cities. We've done projects with San Diego Gas and Electric around the city of San Diego. We have some beta tests running with other cities right now. There is so much promise around the lighting. When we look at the lighting going out in the street lighting, bring the cost down, those kinds of things. The next layer is what else can you do? I think that's a great question there, and you start running into the should versus could question. There's lots of stuff we could do.
Right.
What should we do together with the municipalities? So there are opportunities to do items like Shot Spotter is something that we have, where we put microphones on the lighting fixtures around in the outdoors. And if there's a gunshot, it can triangulate, know exactly where the gunshot occurred, notify the authorities and make sure that someone's heading to that direction. We have things where we can look at crosswalk detection and know if people are walking through crosswalks. There's other things we can do around CO2 detection, all these things. So it's turning almost into software where there's infinite possibilities. How do you neck down into 2 or 3 things you really have to do? So working through that process, and we want to make sure that all of this is viable and it all has payoffs for the cities also. So we always lead with the LEDs, and that's a very cost-effective solution. Then we try to figure out what are the right things to put on top, because there's so many things we could do. We got to really come back to what are the things that the city or municipality really needs.
Yeah, what are some of those top concerns that somebody that heads up a department in a city is actually like, oh great, the lights are in, there's sensors baked into them, let's let's do this with it. Let's do X, Y, and Z.
Yeah. You know, the ones that are getting the most attraction right now, parking is a big one. And how do you handle parking within the cities? And you put a couple of cameras up there, you can do parking detection, those kinds of things. The safety concern one, ShotSpotter and the crosswalk, gets a lot of attention also. It's a matter of how do you justify this as you go through it based on the costs that are in there. And we're working with various municipalities on that, but those are really the key ones that kind of jump to the top. Another one that jumps in is how do you use the lighting as a way to set up municipal Wi-Fi? How do you use each one as a Wi-Fi hotspot and set up a Wi-Fi mesh network? Those kinds of things are typically what's happening, because we're looking at the edge device of the LED as being the next physical digital interface. How do we create that as a physical digital interface and do things with it that haven't been done before? One thing we're doing indoor, which is very exciting, is that you can use it as an indoor positioning system, where through the LEDs, different than incandescent bulbs, you can actually send high frequency signals in the light that is imperceptible by the eye, but it can be perceived by the camera on your iPhone. And if you walk around inside the store, it can know exactly where you are, give you directions. There's lots of things that can open up. And
Don't you think that's a little, I hear this example all the time, that like, I'm gonna have my phone, I'm gonna be in a big box store, and it's gonna be like, look, these rain boots next to you are on sale, like it's raining out today. And I feel like I'm gonna walk out of the store and be very creeped out. There's other examples, you're in the parking lot and it sends you a 10% off coupon that's less creepy. So I know we're not talking about energy here, but I feel like it starts with energy savings and then it moves to some of these things, and I'm interested in creeped out all at the same time.
Yeah, I would. It depends how it plays out, and I think that will be a genetic algorithm that will play itself out one way or the other. I would flip it around and say, people sign up for Waze in their car, and they give away their position, their speed, and everything else because they opt into that because they get a benefit from it, because they get better traffic patterns, they get better things. So you build a crowd there. I can't count on my hands how many times I've walked into a Lowe's or a Home Depot and I needed one specific thing and I couldn't find it. If I could just say, where is it? And it shows up on there, I think that's a benefit. So it has to be mutually beneficial. If it turns into 57 ads and then one beneficial thing, maybe it doesn't work. If it's something that's mutually beneficial, I think it does. But one of the things we're doing with this is we're trying to crowdsource solutions. So instead of trying to say, here are the 7 things we want to develop on top of this platform, we're making this information available out to the crowd, and they're coming up with solutions on top of this. So we had a hackathon on this. It came up with 100 different ideas around it, trying to work our way through. We're also opening up our platform to others. Capgemini is now working with
200 or something,
with Current.
Right?
They put 200 people to build applications. So when we think about this Predix data layer that we're putting in there, we want it to be an open system. We want to be able to write apps on top of it. We want our customers to be able to write apps on it. We want partners to write apps on it, and even have competitors write apps on top of it, because we think as we have an open ecosystem that it will unlock a lot of value for our customers, and we think it's the right way to move forward.
Moving back to energy and to Owen, the commercial guy. Can you talk about people that come in and maybe the teams that they're put on and the enthusiasm to crowdsource and write apps for the distribution grid versus your smart city LED applications and solving, parking problems in LA?
Yeah, and it's having the right approach, because we would not necessarily crowdsource a jet engine. just like you wouldn't necessarily
That's good to know.
crowdsource the reliability of the grid, but there's certain applications on top of that that could easily be crowdsourced. And the energy around around trying to figure out how to save energy. How do we unleash more renewables into the grid? How do we save carbon? There is so much energy around it. I was fortunate earlier in my career, I had the opportunity to work right after we had acquired Enron Wind in the wind side, and all the energy around that. I feel a similar thing around current right now, and how people really want to understand how to get distributed energy resources to go ahead and have efficiency, drive down cost, really unleash renewables into the grid. There's a lot of energy around it. It's very exciting.
Well, great. I think that we are just out of time here, and I know that we're going into a break. And so, Eric, I want to thank you for being available for this conversation. It's been great, and I look forward to seeing what Current gets up to in the next couple of years.
Thank you very much.
Thank you.